Hello friends, how are you? How's your life going on? Today we are going to talk about cloud security principles. Okay, uh, so let's start. Here we go. Every enterprise has different levels of risk tolerance, and this is demonstrated by the product development culture, new technology adoption, IT service delivery models, technology strategy, and investment made in the area of security tools and capabilities. When a business unit within an enterprise decides to leverage software as a service for business benefits, the technology architecture should lend itself to support that model. Additionally, the security architecture should be aligned with the technology architecture and principles. Following is a sample of cloud security principles that an enterprise security architecture security architect needs to consider and customize. What? Following is a sample of cloud security principles that an enterprise security architect needs to consider and customize. Service running in a cloud should follow the principles of least privilege. Okay, isolation between various security zones should be guaranteed using layers of firewalls, cloud firewall, hypervisor firewall, guest firewall, and application container. Firewall policies in the cloud should comply with just zone isolation standards based on the data sensitivity. Applications should use end-to-end transport layer encryption. Okay, so application should use end-to-end transport layer encryption. Okay, SSL, TLS, IPsec. IPsec stands for Internet Protocol Security. Okay, SSL stands for uh, Secure Sockets Layer, right? To secure data and transit between applications deployed in the cloud as well as to the enterprise. Ex- Application should externalize authentication and authorization to trusted security services. Single sign-on should be supported using SAML 2.0. Okay, data masking and encryption should be employed based on data sensitivity aligned with the enterprise data and classification standard. Application in a trusted zone should be deployed on authorized enterprise standard VM images. Industry standard VPN protocols such as SSL, IPsec should be employed when deploying virtual private cloud. Security monitoring in the cloud should be integrated with existing enterprise security monitoring tools using an API, right? So once again, IPsec stands for Internet Protocol Security. Okay, SSL stands for Secure Socket Layer, and SSH stands for Secure Shell, right? And here TLS stands for Transport Layer Security. Okay, so we have gone through principles of cloud security here. Okay, next, cloud security architecture plan. Okay, as a first step, architects need to understand what security capabilities are offered by cloud platforms. Okay, platform as a service. Okay, the next, security offerings and capabilities continue to evolve and vary between cloud providers. Hence, you will often discover that security mechanisms such as key management and data encryption will not be available. For example, the need for a AES 128-bit encryption service for encrypting security artifacts and keys as crowded to a key management service. For such critical services, one will continue to rely on internal security services. A hybrid cloud deployment architecture pattern may be the only viable option for such applications that dependent on internal services. Another common use case is single sign-on SSO implemented within an enterprise may not be accessible to the cloud application unless it's a federation architecture using a SAML 1.1 or 2.0 supported by the cloud service provider. So the following are cloud security best practices to mitigate risk to cloud services. Architect for security as a service. Application deployments in the cloud involve orchestration of multiple services, including automation of DNS, load balancer, network quality of service, etc. Security automation falls in the same category, which includes automation of firewall policies between cloud security zones, provisioning or certificates, virtual machine system configuration, privileged accounts and log configuration, application deployment process that depend on security process such as firewall policy creation, certificate provisioning, key distribution, and application pen testing should be migrated to a self-service model. This approach will eliminate human touch points and will enable a security as a service scenario. Ultimately, this will mitigate threats due to human errors, improve operational efficiency, and embed security controls into the cloud applications. Next, implement sound identity, access management architecture and practice. Scalable cloud busting and elastic architecture will rely less on network-based access controls and warrant a strong user access management architecture. Cloud access control architecture should address all aspects of user and access management life cycles for both end users and privileged users. User provisioning and deprovisioning, authentication, federation, authorization, and auditing. A sound architecture will enable reusability of identity and access services for all use cases in public, private, hybrid cloud models. It is good practice to employ secure token services along with proper user and entitlement provisioning with audit trials. Federation architecture is the first step to extending enterprise SSO to cloud services. Refer to Cloud Security Alliance Domain 12 for detailed guidance here. Next, leverage APIs to automate safeguards. Any new security services should be deployed with an API to enable automation. APIs can help automate firewall policies, configuration, hardening, and access control at the time of application deployment. This can be implemented using open source tools such as Puppet in conjunction with the API supplied by cloud service provider. Always encrypt or mask sensitive data. Today's private cloud applications are candidates for tomorrow's public cloud deployment. Hence, architect applications to encrypt all sensitive data irrespective of the future operational model. Don't rely on an IP address for authentication services. IP addresses in clouds are IP addresses in clouds are ephemeral in nature, so you cannot solely rely on them for enforcing network access control. Employ certificates self-assigned or from a trusted CA to enable SSL between services deployed on cloud. Next, log. Application should certainly log all security events that will help create an end-to-end transaction view with non-reputation characteristics. In the event of a security incident, logs and audit trials are the only reliable data leveraged by forensic engineers to investigate and understand how an application was exploited. Clouds are elastic and logs are ephemeral. Hence, it is critical to periodically migrate log files to a different cloud or to the enterprise data center. Next, continuously monitor cloud services. Monitoring is an important function given that prevention controls may not meet all the enterprise standards. Security monitoring should leverage logs produced by cloud services, APIs, and hosted cloud applications to perform security event correlation. So cloud audit from CSA can be leveraged towards this mission, right? Now next, cloud security architecture patterns. Architecture appropriate security controls that protect the CIA of information in the cloud can mitigate cloud security threats. Security controls can be delivered as a service, security as a service by the provider or by the enterprise or by a third party provider. Security architectural patterns are typically expressed from the point of security controls, safeguards, technology and processes. These security controls and the service location, enterprise, cloud provider, third party should be highlighted in the security patterns. Security architecture patterns serve as the North Star and can accelerate application mitigation to clouds while managing the security risk. Okay. In addition, cloud security architecture patterns should highlight the trust boundary between various services and components deployed at cloud services. So finally, the pattern should be leveraged to create security checklists that need to be automated by configuration management tools like Puppet. In general, patterns should highlight the following attributes but not limited to for each of the security services consumed by the cloud application. First, logical location. Native to cloud service in-house third-party cloud, the application may have an implication on the performance, availability, firewall policy as well as governance of the service. Next, protocol. What protocols are used to invoke the service? For example, REST with X.509 certificates for service request. Next, service function. What is the function of the service? For example, encryption of the artifact, logging, authentication and machine fingerprinting. Next, input output. What are the inputs including methods to the controls and outputs from the security service? For example, input equal to XML doc and output equal to XML doc with encrypted attributes. Next, control description. What security control does the security service offer? For example, protection of information confidentiality at rest, authentication of user and authentication of application. Next, actor. Who are the user of the service? For example, endpoint, end user, enterprise administrator, IT auditor and architect. So friends, today we discussed cloud security architecture patterns, cloud security architecture plan and cloud security principles. I hope you must have got knowledge. Thank you very much.